In this lesson, we're going to look at some mechanics of working with random numbers in Python. So let's look at how we can generate those random or pseudo-random numbers. First of all, we're going to import the random module, and that gives us an access to some functions stored in this module. So let's start with the random function that returns the next random floating point number in the range 0.0 to 1.0. So we'll print it a few times so that we'll see three distinct pseudo values side by side. Here they are. So as you can see, this is a pretty good, pretty easy function to begin with, but it doesn't end there. Instead of just printing out these pseudo-random numbers, we can get ourselves into game design. In particular, we can use this random function to emulate the toss of a coin. So let's say we're tossing this coin 10 times. In other words, we're calling this random function 10 times. And if the generated value is less than 0.5, we print, let's say, heads. Otherwise, we'll print tails. Because the scope of this lesson is to illustrate just how the pseudo-random generator works in Python, I will not be adding any more logic in here, but you can imagine you can extend this code into a proper guessing game by adding this guess heads or tails logic. And as you can see, tails and heads, there is a big game design potential. All right, so this vanilla random function is pretty powerful, but there is more. We can actually control the distribution of our random numbers by specifying different random functions. For example, random.uniform for uniform distribution. In other words, it will produce a random floating point number within the range specified by the arguments passed to this function. For example, random.uniform 1 to 100 will produce a floating point number between 1 and 100. In our case, this is 77 point something. And employing the same logic, there is a randint function that will generate a random integer within a given range. Let's run the code and see what we've got. We've got 83, which is within the range 1 to 100. And further extending this idea, there is a randarrange function. Not only takes the lower and upper boundaries for the generation of random number, but also it takes another argument, which is step. So if I want a random integer from 1 to 100, I would have to write 0 to 101 because the boundaries are not inclusive. That is a multiple of 5. I'll supply 5 as the step value, and here you go, 45. All right, next we'll look at the important bookkeeping function called seed. The idea behind it was that we want to seed the random number generator with some value that will change each execution of the program. So in this case, seed function is used to save the state of a random function so that it can generate same random numbers on multiple executions of the code on the same machine or on different machines. So in this example, seed receives 1 as an argument. Let me copy over the print statements. Let's run them to observe the results. There they are, and now we'll do a bit of an experiment. First of all, let's print some sort of a demarcation line just to separate the two sets of outputs. I'll just use equal signs, but that doesn't really matter. You can use dashes or whatever. So let me copy over these constructions a few times just to prove the point, because it doesn't really matter how many of them we have. Because if we'll run the code, inevitably we'll get the same results, despite that we use the random number generator, and this functionality is provided for us by this seed.